Hello, this is our final project for the Introduction to Databases with SQL course for CS50. It is about a database for a company that manages the hiring of superheroes and supervillains, the SuperAgency. This is the entity relationship diagram. These are all the elements of the database, except the system-generated ones. Apart from the indexes automatically created by SQLite based on our schema, we've created 17 additional indexes. Although these indexes may slow down the database's writing processes, they significantly speed up its reading processes. This trade-off seems worthwhile to us, as we anticipate the database will handle more reading than writing, though this could be refined based on practical use. The main dynamics would work as follows. A client, or potential client, contacts the company. We ask for his first name, last name, and phone number. We use a query like this to search for them in the database. In this case, Harry Kane contacted us and provided this phone number. We execute the query. If partial matches are found, we try to confirm if any of those records correspond to that person. If we conclude that the client is not registered in the client table, as appears to be the case here, we register him. The note column can be used to leave any potentially useful note about that client. Usually, at first, there's nothing to note in advance, and in such a case, like now, null is inserted. It can be edited afterward, once the client is registered, or if they were found in the initial search, we proceed to take their order. In the order table, we insert the description of the order, the location for which the action is requested, the timestamp for when the action is planned to start, the timestamp for when the action is planned to end, if it is defined. For the rest of the data that initially needs to be inserted, communication with the client is not required. These would be the order ID, whether manually or automatically generated, the client ID, the date time the order is created, which defaults to current timestamp, a title for the order, to conceptually represent it for identification, a fixed price, which is probably null at first and defined later on. So, in our example, we are registering the order for Harry Kane, who, since he didn't study for tomorrow's exam, wants the superentity storm from X-Men to create a windstorm over his school in Auckland, New Zealand, so classes are cancelled, starting on this date time and ending on this date time. Harry is informed that shortly he will be contacted for a budget and order confirmation. We proceed with the rest of the data. We could insert a specific ID, but we are going to let it auto-generate. Client ID 16, order created at current timestamp, title, windstorm in the school. The insertion of this order record is executed. Once an order is inserted, this trigger automatically inserts a record in the order status supplied table, with the new order ID, and the status ID too. This status ID refers to the label essay to confirm in the order status table, which means that the SuperAgency needs to confirm the order. Here you can see the rest of the possible status labels, and they must be entered into the order status supplied table when appropriate to keep a record of the status of each order, including the timing of each status. The current status and other data of each order can be easily viewed through the order readable view. Now we can add a note to Harry Kane, has mind-blowing ideas. Let's take a look at the entity team readable view. It is useful for several purposes. For example, we can search for Storm from the X-Men, as she is the superentity explicitly requested by the new client, Harry Kane. We see that we indeed have Storm from X-Men. The status column reflects the current availability of the superentity. We established it through the entity availability table, as in for available and out for unavailable. By implementing the datetime column, it's possible to keep a temporal record of when each entity becomes available or unavailable. The current availability can be seen by filtering for the maximum datetime, grouped by entity ID, as we did in these views. We implemented something similar in the entity team table to log entries and exits of superentities into teams, and that's why, in our earlier search for Storm from X-Men, we can see both her availability and her current membership in the X-Men team. We see her ID is 661. The next thing we need to do with her is register her in the order entity table. This table is used to define the entities assigned to orders. In this case, we record order ID 16, Storm's entity ID, which we already saw as 661, and a 1 in the requested column to indicate that she was explicitly requested. For entities not explicitly requested, we would put a 0. More on these cases later. We execute the operation and see that a default value of 0 is added in the assigned column. This represents that this superentity is a candidate for the order but is not assigned, represented by value 1, or at least not assigned yet. And that's because, although she was the client's explicit request, and we already confirmed she's operational, there are still other things we as a company need to evaluate. For example, in the superentity table, we created this morality rating column. We established the values using ChatGPT with the prompt to imagine what morality rating each registered superentity would have if judged by the general public, on a scale of 1 to 10. This can be useful precisely when considering and filtering candidate superentities for various orders and assigning them, so their morality ratings align, as far as possible, with the morality rating we assume the actions required for each order would have. In real life, we imagine it makes much more sense for each superentity to decide for themselves which tasks to take on, but we added this column as an exercise to practice SQL. In short, in Storm's case, with a morality rating of 9, she would likely reject and even condemn the task of creating a windstorm at a school to cancel classes. So we have to proceed as we would with orders in which the client doesn't request a specific superentity. We have to search for superentities ourselves and decide which ones to offer. To do this, we must interpret the requirements of the order and select the superentities deemed suitable, filtering them by various criteria depending on the case, whether by superpowers, attributes, gender, race, even publisher in rare cases, and/or, as explained earlier, morality rating. In our case, to find an alternative to Storm that could generate a windstorm, we could filter among the available superentities those with a wind or weather-related superpower and a morality rating of no more than 7 at most. If simply analyzing the results, we determine we can assign one or more superentities. For example, in this case we could think, to create a windstorm, who better than the superentity windstorm? We insert their IDs into the order entity table alongside the order ID, with the value 1 in the assigned column. If we are unsure, we can insert into the order entity table the IDs of those superentities we preliminarily consider possible candidates, along with the order ID and the value 0 in the assigned column, indicating that they are not assigned but are candidates. We can do this one by one if we want to choose a few candidates, or all of them together if we think that's better. Once we have the candidates, we can further analyze them with various queries to tables and views. We can study, for example, their powers, their attributes, or even their gender and race, if that becomes relevant in specific cases. The company could also contact the superentities during this stage to do everything necessary to determine which superentities to assign. When we know which superentity or superentities to assign, it's done by changing the value from 0 to 1 in their respective record in the order entity table. There could even be more than one, but in our case, Weather Wizard is enough, and even better than Windstorm. Now we can see him assigned to order 16 between all the rest unassigned candidates. We can now set a fixed price. How the price is established is out of the scope of this project, luckily. We can see the changes in order readable once we communicate the proposal of the assigned superentities and the budget to the client. We record the new order status ID 3 corresponding to client to confirm. If they want other proposals, the process is repeated with any variations deemed appropriate. Once the client confirms and pays, their payment is recorded. The total balance of each user can be seen in the client full view, which, in addition to the basic data of each client, includes total charged, which is the sum of all the amounts charged to them, total paid, which is the sum of all their recorded payments, and balance, which is the balance of all their payments minus the total amount charged. Additionally, It includes the self-explanatory column last order at. Once the client's payment is recorded, and we see that he is debt-free, the order status for is recorded, corresponding to confirmed. We can see the changes in order readable. When the order begins to be executed, status 5 is recorded, which corresponds to ongoing. If for some reason the mission fails or is cancelled, we should register status 6 or 1, respectively. When the order is successfully fulfilled, status 7 is recorded. We created the punctuality view, which could serve to analyze, punctuality, based on the scheduled start and end times of the orders versus the actual start and end times. As we have seen before, we also include teams in our database. Team table to register the teams. Entity team table to link entities with teams. Entity team readable view to display the data in a more readable way. It also has a trigger that we will explain later. So full or partial teams could be requested by a client or offered by the company. The dynamic is similar to when searching for and assigning individual superentities but using the teams table. We could, for example, assign an order to an entire team or add an entire team as candidates and then decide which of its members to assign to the order. This concludes the dynamics of order handling and the required insertions. Now we are going to briefly show the process for adding new superentities to the database. Suppose, for some strange reason, a client requests Jaina and Zan, the Wonder Twins.
Wonder Twin powers activate!
We search for them in our database and don't find them. In such a case, the company would contact them and offer them employment with the agency. If they accept, they would then be registered in the database. Of course, data could be inserted directly and, let's say, manually into each of the tables. But by using the views and triggers we created, data can be inserted much more quickly and flexibly. For example, for the superentities table, we created a trigger that activates when trying to insert into the superentity readable view and instead inserts values into the superentity table but with several advantages, which we will demonstrate next. First, we will show that we have a race table. In this table we search for Exorian, that is the race of the Wonder Twins, and we don't find it. Note that the entity the High Evolutionary is already registered. Now we're going to attempt to insert the Wonder Twins and the High Evolutionary. We have intentionally written this insert command somewhat sloppily to demonstrate how the trigger handles it. We enable list mode to better show that leading and trailing white spaces are automatically removed. At the same time, we can notice that it correctly handles any possible case differences. Also, for columns with foreign keys, it allows inputs as integer IDs, or strings. And if any strings are not in the database, as we saw in this case for the Exorian race, they are automatically added. We also see that by default, a record in for availability is added for each new superentity, or out it specified as such. Finally, it ignores superentities already in the database, applying trim and collate no case for comparison. We roll back these last actions to use the same examples to show another insertion method we developed. This one enables the user to review more closely the data to be inserted both for the superentity table and for the other superentity-related tables. It involves a series of commands that achieve the same results as the trigger we just saw but also incorporate the temp superentity table, which serves as an inbox to visualize the results of all automatic and manual processes we may decide to do before dumping the data into superentity table. For adding superentity powers, we also have both methods, the one of the view and the trigger. And the one of the inbox table. Perhaps the latter doesn't justify its use in the case of the Wonder Twins because they have few powers, not much to review. But other superentities have many powers, as was the case with Silver Surfer, and there, it's really useful. For adding or removing superentities to, or from, different teams, we created a trigger that activates when trying to insert such relationships into the entity team readable view. which instead inserts values into the team and entity team tables with the same flexibility as the previous triggers regarding leading and trailing whitespaces, case, and handling both integer team IDs and text team names, and adding those not in the database. For adding attributes to each superentity, direct insertions are used since the attributes are the same 5 for all entities, so there's not much to review, only the integer values for each. With this, we've finished reviewing the main dynamics of this database as it currently stands while making this video. Maybe we will continue making changes in the future or even integrate it with other projects. We hope you liked it, but just in case you didn't,